All right, welcome back to your favorite pre-calculus expanded course. We're going to take a look at solving rational equations. I'm sorry. So with rational equations, we just got an equal sign between the rational expressions, right? So we're just going to solve the value of x that makes that true. Oops, I don't know why I did that. So let's go ahead and look at this first one. So what we want to do is we want to get common denominators and then eliminate those. So let's go ahead and do this first one here. We got x over 4 equals x over 5 minus 3. Now this is 3 over 1. So we want to go ahead and get a common denominator of 5. So this ends up being x over 4 equals x minus 15 all over that 5 now, right? And so what we can do here at this point is we can multiply. It's kind of like if I had x over 4 equals 7. Like I would just multiply both sides by 4. All right, so x equals 28. So that's what I'm going to do here. Now that I've got one fraction equaling one fraction, I'm just going to multiply both sides by the 4 first and see how it'll clear that out. All right. So now I have x equals 4 times the quantity x minus 15 all over 5. And I can do that same thing with that 5 right there. I can go ahead and multiply this side by 5 and that side by 5. And now I'm not dealing with any fractions here. I'm going to go ahead and distribute that. So I got 4x minus, what was that, 60? And then we solve for x. So we got x equaling negative 60. Next one's a good you try problem. If you want to get a common denominator, pause the video. Great. Get that common denominator 4 here. Now we've got one fraction equaling one fraction. So let's go ahead and clear out the 3, multiply both sides by 3. And then we'll clear out that 4, multiply both sides by the 4 as well. So we've got 4x equals 3 times the quantity x minus 20. So we also get that x equals negative 60 there. Hopefully you're looking at this next one as well thinking, well, I got to get a common denominator of 5x on the left-hand side. So we got 1 over x plus 1/5 equals 7 over x. And I would note right away, if you've got a variable in the denominator, go ahead and note, hey, x cannot be 0 here, right? Like we cannot divide by 0. So if my answer ends up being 0 at the end, I have to throw it out because it's not defined at 0, right? So our answer has to be something other than 0. But let's go ahead and get a common denominator. I'm going to multiply this side 5 and 5. I'm going to give this one an x and an x. And it looks like I have 5 plus a 1x all over 5x equals 7 over x. And so at this point, we can go ahead and clear out our denominators here. So I'm going to multiply this side by 5x, that side by 5x. And notice here my x over x does cancel right there. So we got 5 plus x equals 35. And we just solve for x. So it looks like our x ends up being 30 on this. Note that it could not be 0, right? We got 30, and you can always plug it back into the original, make sure that it checks out. All right, check your answer there. Next one's a you try problem. Similarly, if you want to try that one, pause the video. Go ahead, pause the video if you need to take a look at that work there. It should end up with 18. Notice that x could not be 0 in the first place. If I'm looking at this next one, now notice here, x cannot be negative 1. So note that, right? I cannot have an x being negative 1. If I get that as my answer, I have to throw it out. That will not be my answer. All right, let's go ahead and work the problem here. I got 1 over 1 minus 2 over x plus 1 equals 2x over x plus 1. I'm going to get a common denominator of x plus 1. So I have x plus 1 times 1, or x plus 1, all minus 2. This is all over that x plus 1. Again, the whole name of the game is I want to get one fraction equaling one fraction, right? One rational expression equaling one rational expression. And notice we have it right here. X minus 1 over x plus 1 equals 2x over x plus 1. So I'm going to multiply this side by x plus 1. Notice that'll get rid of that. X plus 1 over x plus 1. And then this is the same thing. So it's going to go ahead and get rid of that one. So we've got x minus 1 equals 2x. And so I'm going to get all my x's on one side. It looks like x ends up being negative 1. Now, remember in red, we said x cannot be negative 1. So this is what's called, this is an extraneous solution. It's a solution that appears to be a solution, but it does not satisfy the original. I got to throw that out. That's an extraneous solution. Well, there's no other options for solutions. That was our only option for a solution. So we just say, oh, no solution then. That was an extraneous solution. X could not be negative 1. We knew that from the beginning. Go ahead and try that next one. Think about what y cannot be also initially. Hopefully you notice y cannot be negative 5, right? You better not have negative 5 on that one. If you did this problem, hopefully you notice at the beginning that y cannot be negative 5. Well, if you work it out, it ends up appearing that y should be negative 5, but we know this is an extraneous solution. Y could not be negative 5. So similar situation as the last problem, we got no solution here. Yeah, and good. So hopefully you notice here, y cannot be negative 2. That would make that denominator 0. And from over here, y cannot be 3 either. So those, I got to throw those out if they end up being solutions. All right. So let's go ahead and do the problem. Now the nice thing is I already have one fraction equaling one fraction. So we can go ahead and clear out our denominators. Let's multiply this side by y plus 2. Means I got to multiply the other side there by y plus 2. And then that y minus 3, let's get rid of the y minus 3, multiply that side by y minus 3, which means I got to multiply that left-hand side also by y minus 3. So we got 7 times y minus 3 equals 6 times y plus 2, and we'll go ahead and finish this up. Get all my y's on one side, get all my numbers on the other. Let me add 21 to both sides. So I got 7y minus 6y is a y. 12 plus 21 ends up being 33. I got to make sure that 33 is not negative 2 or 3, right? Negative 2 or 3 I would have had to throw out. But 33 is fine. And you can always plug it in, right? Plug it in, check it, make sure it checks out if you'd like to. Similarly, go ahead and try this next one. You try it. Go ahead and pause the video and try that problem. So here, hopefully you notice at the beginning that x can't be negative 5/4, right? If I let 4x plus 5 equals 0 and I solve that, right, that can't be 0. So x cannot be negative 5/4. And then over on the other side, it's positive 6/4 or 3/2, right? Can't be 3/2. But this one ends up being negative 4, so we don't have an issue. It's not an extraneous solution. Negative 4 would satisfy that one. Let's move on to this next one here now. Hopefully you notice 3x can't be 0, so if x cannot be 0 from that one, same thing over here, x can't be 0. So let's go ahead and get one fraction equaling one fraction by giving this a 3, giving this one an x. So it looks like I got 4x plus 5 all over 3 equals 8x minus 3 all over 3x. Now I'm going to multiply this side by 3x, this side by 3x, and notice when I do that the 3's cancel right there. So I've got x times 4x plus 5 equals 8x minus 3. So I got 4x squared plus 5x, equals 8x minus 3. So hopefully you're looking at this now and noticing, hey, I've got a quadratic that I'm solving here. Got a quadratic, get one side equal to 0. Add 3, add 3. So we got 4x squared minus 3x plus 3 equals 0. Gosh, son of a gun, you guys. I copied this wrong. I just realized this. See how at the beginning I had this 3x right there? I don't know why I didn't bring that down. I'm supposed to have an x right there, which means that whole thing cancels. I'm so sorry. So it's just a 4x plus 5 right there. My bad. Just kidding. So we're just right there. We got 4x plus 5. Sorry about that. Get all your x's on one side. Don't have to deal with a quadratic here. Divide both sides by 4. Sorry about that. X is 2. Well, remember, x just could not be 0 on this one, so 2 is totally fine. But go ahead, pause the video and try this next one. Get that common denominator 5x, so we've got one fraction equaling one fraction, so can't work through that. And go ahead, check yourself. Should end up with 7, which is not 0, so you're fine on this one. Again, you can always plug it back into the original and make sure it's a true statement. All right, here this next one we've got another set that we've got to think about. Well, 5x plus 7 can't be 0, so if I solve that, x can't be negative 7/5, and then over here, x cannot be negative 3, right? So the nice thing about this problem is I've already got one fraction on the left, and I've got one fraction on the right. So let's go ahead and start clearing out these denominators. And multiply both sides by 5x plus 7. I'll clear that left-hand side out. Let's multiply both sides by x plus 3. X plus 3. And so we've got x plus 3 times that x plus 6 equals 5 times the 5x plus 7. And so we are solving a quadratic on this one. Looks like we got x squared plus 6x plus 3x plus 18. Over here we got 25x plus 35. And so we've got x squared plus 9x plus 18 equals 25x plus 35. Well, since we're solving a quadratic, let's make sure we get the one side equal to 0. So we get x squared, let's see, that'd be minus 16x. That's minus 17. So this will factor for us. It's got to be x and x. It's got to be a minus 17, a plus 1. So x minus 17 equals 0. So x equals 17. X plus 1 equals 0. So x equals negative 1. And then check. The original said we can't have negative 3 and we can't have negative 7/5. So both of these are actually solutions, 17 and negative 1. Both of those will satisfy the original rational equation. Go ahead, pause the video, try that next one. Go ahead, check yourself on that problem. Should end up with 12 and negative 1. As long as you didn't have negative 9/8 or negative 2, it'll be fine. So both of those are solutions on for that rational equation. Now let's try it with a quadratic on the bottom. And so here on this next problem, I would go ahead and factor that x squared minus 44. And then just take a look and see what you have here. We notice we do have difference of squares, but I have one fraction equaling one fraction. So I'm all set up to start clearing out these common denominators, but I do want to think about what can x not be. X cannot be 12 from that first one, and it cannot be from that one. X cannot be negative 12. And over here, cannot be negative 12. We've already listed that. So negative 12 and 12 I'm going to throw out. Those cannot be solutions. Now let's go ahead and start clearing out this x minus 12, x plus 12. X minus 12, x plus 12. I multiply both sides by x minus 12, x plus 12. And notice over here that x plus 12 is going to go ahead and cancel. And so we've just got a 3 on the left equals 2 times x minus 12 on the right. So I got 3 equals 2x minus 24. I'm going to go ahead and solve by adding 24 to both sides here. So I got 27 equals 2x, and I'm going to divide by 2. So 27 over 2, and that's fine. As long as it wasn't 12 or negative 12, I was okay with this one. So why don't you just try that one and similarly think about what you're going to throw out and then try and solve that one like that last part. If you want to pause the video. Sure, end up with 17/5 on that U-try problem. As long as it's not negative 3 or 3, it's okay. So we did get 17/5. Of course, you can always check that in the original. Let's go ahead and move into this next one. Notice x cannot be, cannot be 2 from that one. And from that one, it can't be 0 either. All right, so 2 or 0 I got to throw out. But I don't have a common denominator yet, so I got to get a common denominator on this left-hand side. Right-hand side with 2 is fine. So let's give this an x and an x. Let's give this one an x minus 2 and x minus 2. And then we'll have one rational expression on this left-hand side. This is all over x times x minus 2. And that equals 2. So we got 3x plus 2x. I got 5x. 2 times negative 2 minus 4. This is all times x minus 2 equals 2. And I'm going to go ahead and multiply both sides by this x minus 2. So I got 2 times x minus 2. I'm going to go ahead and just distribute the 2x there. So I got 2x squared minus 4x equals 5x minus 4. So we're solving a quadratic here. I got to get one side equal to 0. So let's go ahead and do that. And then see if this will factor. And it should factor. Let's see, that'd have to be 4 and 1 and a minus. And the minus will work out for us. So it looks like x ends up being a half or 4. And make sure, remember the original, it couldn't be 2 or 0. So 1/2 and 4 will work out. Of course, if I was doing this on a test, I'd go ahead and check those in the original and make sure they check out for me. Why don't you try that next problem similarly? Looks like we end up with 4/3 and negative 1 here. And from the beginning, we couldn't have negative 2 or 0. Right? So those two are fine. Those two are fine. I want to pause that, take a look at that work. That'd be great. Let's take a look at this next one now. Notice from this one, x can't be 0. From that one, x can't be 3. Same thing over here, x can't be 3. So 0 or 3, I'm going to throw out. So let's go ahead and solve this now. We've got to get a common denominator on this left-hand side so we can get one fraction equaling one fraction is the name of the game. So we're going to have to give this an x minus 3 top and bottom. We're going to have to give this one an x and x. And so we have 4 times that quantity x minus 3 plus 2x. This is all over that x minus 3 common denominator. Let me distribute that. And notice now I've got one fraction over one fraction. So let's go ahead and start clearing out. Multiply this side times x minus 3. And notice The x minus 3's cancel on the right hand side. So the left hand side I got 4x minus 12 plus 2x equals x times x minus 1. Well, 4x plus 2x gives us 6x minus 12 equals x squared minus x. I am solving a quadratic, so I got to get one side equal to 0. So I've got 0 equals x squared minus 7x plus 12. And so we'll go ahead and multiply by minus 3 and minus 4 here. Or, I'm sorry, that'll factor into minus 3 and minus 4. So x will be 3, or x could be 4. Now remember from the original, I couldn't have 0 or 3, so I got to throw out that 3. That's an extraneous solution. This is extraneous solution. So the only one that works is the 4. So I keep the 4 as our solution here. This next one, I've noticed that 4x plus 12 is not factored. I'd go ahead and factor that first before we think about doing anything. So I've got x over 4 times x plus 3. So x can't be negative 3 there. Over here I've got an x plus 3 minus a 3x over, again, factor that. So just note x cannot be negative 3. That would be an issue here. And now let's get a common denominator. Notice this one's just missing a 4. And so the common denominator would be 4 times quantity x plus 3 there. And so we've got x over 4 times quantity x plus 3 equals, I'm going to distribute that, 12x minus 32 minus 3x. This is all over that common denominator 4x plus 3. So we're going to go ahead and multiply both sides times 4x plus 3, 4x plus 3. And notice those all will cancel nicely for us. So we've got x equals 12x minus 3x is a 9x minus 32. Let's subtract 9x here. We'll just got it linear here. Negative 8x equals negative 32. Divide by negative 8. And we just end up with x being 4. And remember at the beginning, x could not be negative 3. And so this is fine. X being 4 is perfectly okay. It will not cause division by 0. If you want to go ahead and pause the video on this next one, that'd be great. Go ahead and check yourself on that one. Should end up with 42/5 on that one. And pause it if you need to. Let's jump into the next one. Notice I've got a difference of squares. So from the y minus 10, I know y cannot be 10. From the y plus 10, negative 10, right? And then from that one, 10 and negative 10. So let me erase that part right there. Now let's get a common denominator. This one's already got a y minus 10. Let's give it a y plus 10. Top and bottom. So we've got 6y plus, I'm going to distribute that, 9y plus 90. This is all over that common denominator. Y minus 10, y plus 10 equals 5 over y plus 10. Now we have one fraction equaling one fraction. So let's multiply this side by y minus 10, y plus 10. Notice those y plus 10s cancel. So we got 6y plus 9y, got 15y plus 90 equals, and then distribute that 5y minus 50. Solve for y here. We got 10y equals negative 140. Divide by 10, y equals negative 14. So, which is fine. I just couldn't have y being 10 or negative 10 on that one. So y is negative 14. So this next one, again, it's not, right now it's not factored. Let's go ahead and factor this first. So notice x cannot be 3 or -5. 3 or -5. And now let's go ahead and get a common denominator. So this needs an x plus 5, x plus 5. This one needs an x minus 3 and x minus 3. So it looks like we have 6 times the quantity x plus 5 plus 2 times the quantity x minus 3 all over this common denominator of x minus plus 5 x minus 3 equals 8 over x plus 5 x minus 3. And notice if we multiply both sides by that x plus 5 x minus 3, it's going to cancel those common denominators, x plus 5 x minus 3. And so we've got 6x plus 30 equals, plus 2x minus 6 equals 8. 6x is still got 8x, 30 minus 6, I got 24. I'm going to subtract 24 both sides, so I got 8x equals a negative 16. Divide by 8, and I get negative 2. Well, notice originally x just could not be 3 or negative 5 on that. Next one is we've got a U-try problem. If you want to pause the video, that'd be great. Should end up with a negative 1/5 and negative 8 on that one. Negative 4 and 1 could not have been a solution on this one. And let's look at our last one here. We've got 3 over x plus 7. Let's go ahead and factor this. Notice this will factor into plus 7 and minus 1 there. So x cannot be negative 7 from the x plus 7 denominator, and x cannot be 1. Negative 7 or 1 I'd have to toss out. Let's get the common denominator here, multiply by x minus 1, give this an x plus 7, x plus 7. And so we've got 3 times x minus 1 minus 6x plus 7 times x plus 7. This is all over that x minus 1, x plus 7 equals 13x minus 7 over x plus 7, x minus 1. Well, notice if we multiply both sides by x plus 7, x minus 1, we're just left with these numerators here. So we've got 3x minus 3 minus, now this will FOIL out, so I'm going to put this in parentheses, 6x squared plus 42x plus 7x plus 49 equals 13x minus 7. That'll give me 49x in the middle, and then I'm going to distribute that. So the 3x minus 3 minus 6x squared minus 49x minus 49 equals 13x minus 7. So we got negative 6x squared. 3 minus 49 gives me negative 46x. Negative 3 minus 49 gives me minus 52. Equals 13x minus 7. I have a quadratic. I want a positive, so I'm going to take everything over to this other side. So we got 6x squared. 46 plus 13 gives us 59x. I got 52 minus 7 gives me what? 45 on that. And let's see if that'll factor here. I think that'll do it. 6x squared, 30, 54 plus 5. There it is. So we got negative 5, 6. I got negative 9. Remember at the original, it couldn't be negative 7 or 1, so that'll be okay for us. And thanks so much for Take notes. See you next time.